Now, this is a concept that very few people understand, the role of the p-value in Table 1. Watch this video to learn what it means. My name is Rhanderson Cardoso. I'm a cardiologist in Boston, Massachusetts. I trained in cardiology at the Johns Hopkins Hospital, and today I work at Harvard Medical School. And in this channel, in the Meta-Analysis Academy, I teach you how to produce research independently, and with that, you transform your career through the publication of high-impact papers. Do you know what is the purpose of a Table 1 in a publication, in a clinical trial, or in an observational study? Let's take a look at it right here. In this example here, we have a study, a publication that compared two groups of patients. Patients underwent cardiac surgery and were discharged with clopidogrel or without clopidogrel. So this is a very simple, straightforward clinical question. So Table 1 in a study like this serves for us to understand the baseline characteristics of the individual patients in the study. It helps us to understand the age of these patients, the distribution of sex, race, and comorbidities like hypertension, diabetes, smoking, and so forth. So this is the main purpose of Table 1, is to share with us the characteristics of the patients included in the trial or in the observational study. And do you know what this p-value here on Table 1 means? First, remind ourselves what is a p-value. So a p-value is the probability that such a difference between both groups, in this case, in the distribution of these baseline characteristics, it's the probability that that difference was obtained by chance alone if the groups were in fact similar to each other. In this case, we have here that, for example, that the distribution of patients with diabetes is very similar between both groups. It's 36.5% in one group and 37.8% in the other group. So the p-value here is not statistically significant. What that means is that if these two groups are in fact the same in terms of diabetes distribution in the hypothetical population of these patients, in this sample, the probability that they would be this different from each other, 36.5 and 37.8, by chance alone is more than 5%. It's 45%. So we accept that these groups are likely very similar to each other in the distribution of diabetes, at least from a statistical perspective. On the other hand here, we see that there is a large difference in the proportion of hypertension between both groups. Over here we have 78% of patients with hypertension. Over here we have 83%. And the p-value is less than 0.05. It's 0.001. So it's 0.1% the probability that this difference was obtained by chance alone if in the population of these patients, the distribution of hypertension was in fact similar between both groups. So that's what the p-value tells us. It's really what's the likelihood that such a difference was obtained by chance alone, and not really because the groups are in fact very different from each other with regards to the characteristics of hypertension. Now realize that this p-value should only be present in Table 1s of observational studies. Why is that? Because in randomized controlled trials, provided that randomization is done well, any difference in baseline characteristics is in fact due to chance alone. Because we're leaving it up to chance, we're randomizing patients into one group or the other. So there's no purpose in putting a p-value column in Table 1 of randomized controlled trials. But in observational studies, you might see this column of p-value for Table 1 to help us understand this concept. All right, I hope you enjoyed this video.